My full fill pump controller, this is basically set up to control our fill pumps in two stages. We have our remote one for the primary fill pump and remote two. These are for our secondary fill pumps. And the remote one, which our primary fill pump, that flows roughly around 250 milliliters per hour. The remote two, these are pumps 2 and 3. These are 500 milliliters per hour. Now we can always upgrade any individual pumps on this setup. The way it's set up, I can actually increase the remote one to a 500 milliliter per hour pump also, or take these up to 750 or even higher. But for the moment, that's basically what we're starting off with. But one of the things that I want to kind of set up a little bit different, they recommend or sometimes use a bellow switch for controlling the fill pump for the primary pump. There's several options or a few different approaches you can take to control your fill pumps. Basically, remote one and remote two, they're controlled the same for the most part. 6.5 volts plus will activate either 1 or 2. If you send 12 volts, just say for example to 1, that's going to activate your primary pump. If you send it to 2, that's going to activate your dual pumps pretty much together. I'm basically going to set the system up a little bit different, but basically the remote one, you want your factory setup to be pretty much similar for that connection point right there. A lot of times you would want the relay that activates your fill pump. You can use the control wire off of that to send here and have it grounded on the other end, and that signal wire can come to here. Of course, this is your battery power. This is going to be your ground chassis, so really all you need is just your 12 volts. You can actually piggyback off of that 12 volts that would have operated the factory fill pump and use that to control this. So that way you still utilize a lot of the factory features. For example, if you open your door on some Volkswagen and Audi cars, that automatically primes your fill system. And of course, when you get in and turn your ignition key forward, that primes the system as well. And you can still keep a lot of those controls. Remote 2, there's a couple different options on setting it up. Pretty much 4 recommends you can either, if you want, you can use a Hobbs switch. A lot of times you can call this a pressure switch or something like that, and use this to activate or send a signal if you get to a certain boost pressure. Now this, for example, is a 5 psi sensor, or you can get different ones. Some of these switches, they sell them adjustable, and you can adjust this so that when you hit a certain boost threshold, that'll activate and send your 12 volt signal back to control and turn on pumps 1 and 2. But I may do something a little bit different. With these other pumps, I may actually use some solid state relays to control these. Now this is still a pretty nice setup on the most part. I will probably use remote one just as I stated, let the factory system send an input in here to control that. And this does have some pretty nice protection on the inside. You have your 3 relays that would be for each pump, and each pump has a separate fuse. You got a 20 amp for our pump 1, and for pumps 2 and 3 we got 30 amp fuses in place of those right here, which is pretty good, and that's just an extra backup protection in case you blow the fuses if they start pulling quite a few amps more than the fill pump is rated for. I have a few different things and options I can consider. For example, if you're doing just some daily driving on the streets and you only hit it once in a while and you only have your car pretty much tuned, just say for example a street tune, and you're running 93 octane and you're pushing no more than, I would say, 800 horsepower, it may not necessitate for you to have all 3 fill pumps running. You may only need 2 pumps, the primary and just maybe 1 secondary pump kicking in. And having all that extra fuel kicking in, even if you're staying into it for a few minutes, having all 3 pumps running, heating up your fuel supply, it may not necessarily be the best option. But we do have the ability, if I want, I can pulse width modulate either one of the second or third pumps or both of them together. If I wanted, for example, the second pump to kick in, just say, for example, at 20 psi, or 25 psi, then I can have one of these solid state relays kick in on that, or I can have the third one kick in at 40 or 50 psi, depending on how we set it up. And pretty much with the MOTEC system, is pretty much to our discretion how we want to set it up. But that would be my consideration. Other than possibly running a pressure switch, I would use the MOTEC and the factory, not the factory, but the aftermarket map sensor that we're using. When I do hit a certain boost threshold, then I can bring in my second or third pumps. That's one of the things that I'm using. These are some awesome solid state relays, and these are heavy duty. They can handle running heavy duty fuel pumps, and I want to say pretty much in an industrial manner for the most part. So basically, I've seen in a lot of the applications that I've worked in, background in industrial automation, I've seen these type of SSRs, solid state relays, for the most part, run continuous for 20 hours straight, under load, running, controlling whatever type of device you have connected on the other end, and only get a 4-hour break just for downtime when we go to service equipment, do maintenance, and make sure everything's up and running, and then back at it, another continuous 20 hours straight. None of us are really driving our cars like that on the average, and these things are more than durable. And I've seen these honestly last on an average 5 to 10 years without any problem. So for applications like that, this would be something pretty cool to do and have some good reliability. This one is a 40 amp. I can use this as an extra protection, even if I wanted to, say, just control pump 1 if needed. I have some 60 amps. This is an 80 amp. This can control both pump 2 and 3 if I wanted to control those two together, bring them in, and then pulse modulate them. So that way I'm not just ramping in a whole bunch of fuel all of a sudden. I can just modulate both of those together. I can do them individually with separate solid state relays, or I can bring them in together, which would be a nice hit, and to just modulate both pumps simultaneously, which would be pretty cool. This relay right here, this is a 100 amp relay, and that definitely can carry both pumps right there, and pretty much it can carry the whole system. For the most part, all 3 pumps can run off of this. Now, this relay is pretty expensive. Just this relay itself will run anywhere on an average, I want to say around $185 to maybe $220. But these are expensive. But these are the good ones, not any type of knockoff product. So you would definitely have to be careful if you went a solid state control route and wanted to control your fuel system using something like this. But for someone that's going that route to use a solid state relay to control that stuff, there's definitely several precautions you would definitely have to take up to run something, especially any type of heavy duty coil, motor, relay, any type of heavy duty switching circuit. You definitely have to take the precautionary measures. Like, for example, on these, you definitely want to use a thermal grease or a thermal pad. Have that between your solid state relay and whatever type of heat sink you're using. I have a few different style heat sinks. These are some like the original Crichton heat sinks. These heat sinks are pretty cool. They snap onto a DIN rail. If you needed to get these off, you would just get a flat tip screwdriver from the front, prop this up, and then it comes up off the rail. To pop it back in is the same. Pretty much you clip it in from the bottom and then just snap it, and this is spring loaded. That'll just pop this in position. But you definitely want to have these things that can generate some heat. That's why these heat sinks are very heavy duty, and you want to definitely have this away from anything that can possibly melt, any type of plastics or something like that. They don't overheat to the point where they're super hot, because, for example, this still has a plastic cover, and I haven't really ever seen any of these melt up. But you definitely want to have a good quality product, and it's several knockoffs on the market. I mean, several. If you're going to purchase something like this, you want to purchase from a reputable supplier and make sure you're getting the real product and not just some fake knockoff that's going to burn up and burn up your fuel pump, or the relay burning up and you just be stranded on the side without having good quality product. That's one of the things I would advise. And also, when you're activating something heavy duty, of course, if it's a motor, a solenoid, or anything like that, you still have to take your precautionary measures for the kickback voltage or any type of reverse inductance. Anything like that, you want to definitely make sure you protect your circuitry. So for example, if whenever you're activating a coil, a heavy duty coil, a lot of the factory or little small relays, if you look at them, something that's energizing, something pretty good, it's going to have an internal diode either built into it, or some may have external, but a lot of the relays may have internal diodes built into it. These do not. So you would want to use a heavy duty kickback diode that will prevent reverse bias voltage kicking back into your system, and that can damage some products. If that was the case with our car, it would damage if the motor pumps was just kicking, pulsing and generating some heat, and it was suddenly shutting them off, collapsing. It could potentially send a voltage, if we didn't have the proper protection, and come back and it would damage the circuitry in this, but it would not damage the circuitry in the MOTEC that is activating it on the input side, because the internal circuitries would block that out and prevent that. It only takes a small amount of control voltage to operate these. I think, for example, this is anywhere from 4 to 32 volts DC, which doesn't take much at all to operate this. And they're high-speed switching, and I would pretty much use the ground from the MOTEC itself, the high-speed switching grounds, to control these, and that way I minimize any type of damage. Of course, as along with these heavy-duty kickback diodes. And these diodes, this particular diode right here, this is expensive, anywhere from $7 to $12 each. And you want to just, like I said, make sure you have some good quality products. And I don't necessarily have to use an expensive diode like that. You can use still another heavy duty diode, but you want to do the troubleshooting and research on something that's going to protect yours. This right here, this diode is rated up to pretty much over 400 volts. So our fuel pumps are not going to be kicking back that much voltage. That'll hurt the system from what I've already measured. But either way, we're still protected a little bit beyond the average, well, a lot above the average, I would say, for safety and operation.
Check this video out now, man. Like, comment, subscribe.